Good morning, and first of all, thank you very much, Nico, and the authorities for giving me the opportunity to stay here today and share part of the work we have done not in NexusLabs, but also in other projects like Nexus I will show you. I'm José González, as Nico's introduced me. I came from the University of Castilla-La Mancha in Spain, and I'm now coordinating and co-coordinating with Ana NexusLabs. And I will show you just one part of the WEFE system that is more focusing on water, and because we see during recent projects that when we did the workshops and some meetings, that water is an essential part of these components in the WEFE. So the context of the work here is, well, this is from the previous European project we coordinated, Nexus. What is the role of the water and how we approach to this in the water domain? So we developed a database accounting water at different levels. We developed other tools, land use, because it's very important, land use, and we developed also climatic projection for the future trends on water consumption, implemented this information in participatory system dynamics modeling, that I will not enter into depth because Virginia is coming up later now. And all of this was implemented offering different catalog of network-based solutions, trying to go further to put in practice and implement all of this in the pilot areas. So water is important. Going into depth, yes, I will show you some cases and some stories implementing this technology. This is the Jauja River Basin in the area of Spain, in the east of Spain, just in the Mediterranean part of the Iberian Peninsula. Just to justify, this is published, it was published in Journal of Hydrology. The leverage of water in this was mapped in a system dynamics modeling, and the water is essential in all the connections between the energy, fuel security, and environmental impact. So the strategy was to develop a model just to manage the water at different scales. We developed it between different models, so we went to a water balance model at 3 scales. At plot farm, because we are just, Nico's asked some questions, the different scales of scaling, so we wanted to work at farm scale, but also at large scale, at river basin or even national scale, we have done. All of this information is published. You can have the presentation and enter into depth how we did and how we validated this. But basically, the model is a balanced model. I will not enter into detail of all the components, but we are focusing more in evapotranspiration, how we approach. There are basically in remote sensing 2 approaches to evapotranspiration: the water balance and the energy balance. We choose the water balance in this case, but we are working as well in energy balances. Basically, we wanted to work at different scales, a commercial plot, because we have to assess the farmer as a stakeholder in order to have this information as soon as possible in time and in space. At Water User Association, that is a common structure in Mediterranean areas, we can provide this information. Also at aquifer scale, because water managers at the aquifer scale need this information. And also river basin and regional scale. I will show you how we have implemented. Basically, the information we need is to run a water balance model. It's just like a bottle of water. So we need inputs, outputs just daily. We use the time series of satellite images. In this case, we use Sentinel, but we can implement any other information from the satellite we have, together with land use maps, if we have, if not, we develop, and the net of stations. Now, the most operational instrument is the meteorological agency maps to determine the reference about transpiration, and the soil map, basically. This information is what we need, and we develop these outputs But basically what is most important is net irrigation requirements. We developed the model just for water accounting, just providing how much water is consumed or is needed to irrigate, but also as an environmental indicator, the water footprint, because in Nexus we saw that was an interesting indicator in that case for at plot scale, was developed. So at pilot farm, it's possible that non-specialized user can use this tool because it's now implemented online in a cloud platform. So it's operational, you can use at farm. So what we only need is to train the stakeholders. Yes, it's what we need now. But at the level of water user association, what we have is on a real business scale specialized, because you have to manage a large amount of information and you have to have the skills to do it. At plot farm pixel level, well, we distinguish, because it was a great discussion at what is the farm level operational. Now we agree that the plot, if we use the vectorial plot as the level of information that is useful, this is a tool just provide information, and you have to monitor daily the inputs and outputs, and basically the irrigation, the water consumed, and the irrigation that we need. This is an example you can see. Another very, very interesting tool that is being used and commercialized with AgriSat is the IRRI-Maps. That is, we implemented the necessity of water that is needed for the next week, because the farmer uses the soil as a reservoir. So it's very important for them, because there is an important connection between the energy and the water here. Depending on the type of soil and the cost of energy, they manage weekly to feel more, less, depending on the price of energy and the excess energy and the field capacity of the soil. But at the river basin, it's very important for the authorities also to manage the water per crop, per area, and per aquifer domain. Here, two examples, we have more. This is the Júcar in the left and Piños River in the right. Okay, we have done in the Nexus, so I put these examples. And we calculated also the water counting for different years, and also the water footprint for each crop and each plot. I will show you an example, very, very recent. We have developed here at regional scale. This is in all the region Castilla-La Mancha. Castilla-La Mancha is the part of the central part of the region in the Iberian Peninsula. You know more or less the Iberian Peninsula is the center. It has around 500,000 irrigated hectares, so you can dimension the volume of water we are managing. This is the 3-year evolution of the total amount of water used. We are talking around 500,000 hectares of irrigation, and also 1,500 cubic hectometers of water each year that is managed in the area. And it's managed, and it's the first time the authorities have a map of crops and a distribution in space and time of the water that is used in the area. I mean that because it's very important to provide this data to do an evaluation of the data we are providing. This is a case you can, well, they are published. This is the case of an evaluation at the aquifer scale using the piezometers, because we have to upscale all the calculations at different levels. And well, it was done for 3 years, and we are continue doing this evaluation to know how the piezometers, the evolution of the piezometers with the evolution of the calculation of the satellites not always is the same, so it's needed a good hydrogeologist interpretation of the underground system. But the important thing is that, for example, look, this plot in black holes is how traditionally the authorities manage the water with the river basin plan. This is the river basin plan in the Júcar. And the blank dots are remote sensing estimations, average in all the Mancha Oriental aquifer. The area below the curves is the same, so the volume, total volume, more comparable. But what is particularly interesting is how the timing is different. Why? Well, in this case, we diagnosed the problem is due to the adaptation of the crops and the irrigation management from the farmers. Due to water scarcity, they moved to spring crops more than summer. So the management of water is different during the last year than previous. So the evolution of the water management at large scale is different. This is an example of validation at farm scale. This is a farm in the area. It's named, well, it's a well-known farm there. And we used different years with the flow meters to validate in order to know this, more or less, what is the uncertainty that we are introducing here. Well, there are some issues that we are just studying now in order to have this validation. For example, the efficiency in irrigation is very important in order to adapt this calculation. But basically, we are between 10 to 20% uncertainty in these calculations at farm scale. Yes, I want to introduce another examples because it's in Spain it's important. I don't know if you are conscious of in Greece or in other countries of this. This is a report of WWF in Spain last year. I don't remember if it was in the year 2018 or 19. Basically, these are the 4 sites in Spain where water robbery was done. There was an alarm in Spain about that, and the report says, why Spain is the worst country in Europe in order to get water from the thief of water, basically. So there was an alarm because the situation was out of control from the ministry, and some areas were just... we in the remote sensing unit, we were asked for the ministry if we can do something on this, just to manage how much water was stolen there. And about the sustainability of the aquifers that were under the risk, those 4, we selected one, that is Arenales, in order to do a quantitative evaluation of the situation and to know the sustainability of them. In this case, this is El Carracillo is an area that is an aquifer. We prefer to have the control of the aquifer at large scale and at plus scale. And well, this is a reservoir of water that fills the aquifer. The aquifer is filled just using sources that is not seen here, but in the green area in the center is how, well, the points where they fill the aquifer. So there is a control about the abstraction. So they know the water that is entering into the aquifer and the water that is leaving the aquifer. But the alarm was that the use of water was out of control. Well, the situation was this. We developed a cartography about, in green, there is the plots that are declared as irrigation, that has the license to get the water there. And the blue are the other plots where the water is being used. So it was clearly a difference between the control in both, no? And we found that. And, well, the question is, what is the situation there? Because we can, how do we can evaluate this? Well, we cannot evaluate because we don't know where is the flow meter, because the water is out of the plot. There is a market of water there, clearly. Some farmers are selling the water, so it's... And, well, the sustainability of the system can be under the risk. So we evaluated and validated all of the data at the municipality level. It was not possible to do it at the flow. And at the end, we found that more or less we're around 17 cubic hectometers filling, 17 cubic hectometers getting up. So the sustainability of the aquifer was under the boundaries. The problem is that the authorities did not know anything about how the water was being used. So the food security is guaranteed in some terms, but in that boundaries. But there is a market and a commercial issue of the water that is not controlled. So at the end, well, we reported all of this, and this information is open to the river basin authorities that manage it and regulated that market in order to guarantee that the producers continue the activity. And well, the environmentalists were in the same table discussing about the numbers, now about perceptions. No? This is the issue. Finally, I would like to remark something that make me happy. This graph is about a recent publication about a meta-analysis concerning how much publications are focusing on water management using satellite. So you can see how the increase on that publications is during the recent years. So there is a very much interest on doing this technology for water management and evaluating quantitatively those resources, just because it's possible and provides information in time and space. And what makes me happier is that a comment that is in that publication that we don't know the authors, believe me. Just the Spain-La Mancha Oriental Aquifer remote sensing based monitoring was institutionalized within legal and administrative structures supporting conflict resolution and water rights allocation. So, well, Spider Remote WebGIS, that is the tool I told you where Hidromod is implemented, enhanced transparency and participatory governance, and the Spanish Supreme Court even recognized the legal validity of remotely sensed evidence. So, well, just to put in value that this tool is being used and has strong evidence of where the water and how the water is used. Just some recommendations in our experience and in the frame of Nexus of using this technology is that this, I think, is valid for monitoring, but we need validation. It's very important. We are working now in validation strongly. Yes, with flow meters, flow systems, depending on the scales we are working on. No? It's especially useful for managing complex systems, like I showed you Arenales and other, where the irrigation is delocalized. It supports control, monitoring, and transparency strategies for public administration, irrigation communities, and farmers, because we can work at different scales. And, well, accounts and monitoring of water at the appropriate temporal and spatial scale is essential for modeling the energy, water energy environment and food security relationships. In this regard, data provided by remote sensing can offer significant and experimental support. So that's in our experience in previous projects and now in projects that are ongoing, that we have using this technology, because flow meters in all the plots is very complicated to implement. Thank you very much.